So here once upon a time we were discussing about the behavior of the wire. So for that I have taken a plate here. On that plate we are increasing the masses, and then this wire of length L I have taken, original length was L, and now whenever I increase, whenever I put the mass A, let me take MA, nothing but up to point A we are discussing here. Up to point A what happens? Stress will be directly proportional to strain. So only we call it as what? What is we call it as? Proportionality limit. Proportionality limit. Then whenever I remove this MA, what happens? Nothing but it will go back to the original position again. So it will have which nature? Elastic nature. Then after that I have added one more mass, MB. Whenever I have added one more mass, at that time now stress is not directly proportional to strain. But even though whenever I remove these two masses, then what happening? Nothing but the wire is going back to the original position again. So that from O to A and then A to B, which nature is there? Elastic nature is there. But from O to A, stress is directly proportional to strain, but it is not directly proportional in case of A to B. But it is having the elastic limit up to there, so only we call it as elastic limit. The point B is known as elastic limit. Why? Because from O to B, it is having the elastic nature. Next, from B to C. From B to C, what happening? Nothing but if I increase the smaller mass also, MC also, then what happening? Nothing but the wire is elongating, okay, but what happening? It is not going back whenever I remove the masses. So nothing but it is losing which nature here? Elastic nature. So only we call it is yielding. From point B, it is yielding. So only we call it as yield point. Otherwise, permanent set also we can even call. Next, whenever I increase a little bit mass also, that is MD, I have increased little bit stress, then what happening? I am getting more strain. So only we know it as what? Ultimate tensile strength. Ultimate tensile strength, otherwise permanent set. This is also we can call. Now after that, after point D, what happening? Whenever I decrease the masses, whenever I am removing the masses also, then what happening? Nothing but wire is still elongating only. So that what we can say, whenever we even decrease the stress also, the strain is increasing, and up to some point E, it will just strain will be increases. After point E, what happens? The wire will get braked. So only we call it as fracture point or breaking point. And also the materials which are having the region A to D as a longer region is there. Nothing but whenever we are increasing the loads, at that time elongation is increasing, so that type of wires are known as the ductile materials. Whenever this A to D region is very small, nothing but whenever I increase the load and then after that if I add some more mass also, immediately it is getting braked. Nothing but these are near to each other. A to D region is near to each other. At that time what happening? We call it as what? Brittle material. Why? Because there is a chance of breaking easily. See that whenever I come to here, for example, if I take the graph of the brittle material, at that time what happening? Nothing but this is a point A, and then immediately here only we are getting the point D. Then what happens? Immediately here after D, what happens? It will get braked. So that whenever after D it is getting braked, nothing but for the smallest strain also the wire is getting braked. So only we call it as brittle material. For example, ಯಾರೋ ಮಾತಾಡ್ತಾ ಇದ್ರು, ಬಾಯಿ ಮುಚ್ಕೊಂಡು ಕ್ಲಾಸ್ಗೆ ಹೇಳ್ರಿ. ಕರೆಕ್ಟೇನಾ? ಕರೆಕ್ಟೇ ಹೇಳಿದ್ದೀನಾ? ಎಸ್, ಕರೆಕ್ಟೇ ಹೇಳ್ತೀನಿ. ನೀವು ಬಾಯಿ ಮುಚ್ಕೋಬೇಕು, ಕ್ಲಾಸ್ ಕೇಳಬೇಕು. So here this is a point A, and then I have taken up to here I am getting point D. Nothing but what happening? Whenever I increase more strain also, the wire is not getting braked. So I can call it as which material? That is ductile material. Okay na? ಬಾಯಿ ಮುಚ್ಕೊಂಡು ಅಂದರೆ ಬಾಯಿ ಮುಚ್ಕೊಳಲ್ಲ, ಯಾಕಂದರೆ ಮಾಸ್ಕ್ ಹಾಕ್ಕೊಂಡಿದ್ರಲ್ಲ, ಮಾಸ್ಕ್ ರಿಮೂವ್ ಮಾಡಿ ಅವಾಗೆ ಬಾಯಿ ಮುಚ್ಕೊಳ್ರಿ. So here from A to D there is a more strain. More strain, nothing but what happens? The wire should get braked actually. But even then the strain is more also, the wire is not breaking. So we call it as a ductile material. Ductile material. And then here for the less strain also we are reaching the point D easily. After that wire will get braked. So only we call it as brittle material. Clear? What is brittle and then what is ductile? Nothing but more strain. but wire is not breaking, so that is ductile. And then less strain also the wire is getting breaked easily, so only we call it as brittle material. Write that. Behavior of the wire under gradually increasing load, stress strain curve. Draw that first, draw the curve. దానిలోనే ఉందారా ఏసీ వస్తున్నా చల్లగాలి. రైట్ దట్. ఫస్ట్ ఆఫ్ ఆల్ ఓఏ రీజియన్ వస్తుంది. డోర్ క్లోజ్ చేయండి చంద్రు, క్లోజ్ ద డోర్. ఫస్ట్ O2A, ఫస్ట్ వన్ O2A రీజియన్. proportionality limit, proportionality limit. Stress and strain will be directly proportional to each other. Stress and then strain directly proportional to each other. Obeys Hooke's law. Obeys Hooke's law. Next, A to B, elastic limit. A to B, elastic limit. Stress is not directly proportional to strain. Stress is not directly proportional to strain. Does not obey Hooke's law. Does not obey Hooke's law. Does not obey Hooke's law. From O to B, from O to B, wire will have elastic nature. Wire will have elastic nature. Next, B to C, yielding point. Yielding point. E to B nama, B to C nama, B to C, B to C, yielding region, yield point. Otherwise, the wire will loses elastic nature beyond B. Wire will loses elastic nature beyond B and starts yielding. Starts yielding and permanently deformed. And permanently deformed. Next, C to D, ultimate tensile strength. Ultimate tensile strength or permanent set. Or permanent set. For smaller increase in stress, for smaller increase in stress, there is larger increase in strain. Larger increase in strain. D to E, D to E, fracture point or breaking point. Fracture point or breaking point. Beyond D, beyond D, even decrease in stress, even decrease in stress causes increase in strain. Even decrease in stress causes increase in strain. Comma. After point E, the wire will get braked. The wire will get braked. Next one is brittle materials. Brittle materials. Separation between A and B, separation between A and B will be less for the brittle materials, means for the smaller strain also, the wire gets braked, easily. Next line, ductile material. The region A to D, is larger in case of ductile materials, means even for the larger strain also, the wire will not get braked. Draw the ductile and then brittle graphs. Had a problem? If a wire of length 4 meters and cross sectional area, 4 meters and cross sectional area 2 meters square, is stretched by a force of 3 kilonewtons. Then determine the change in length. Due to this force. In bracket, Young's modulus of material is 110 into 10 power 9 Newton per meter square. Get the answer for that. Given length is very easy basic problem. length is 4 meters, area is 2 meters square, force is 3 kilonewtons. How much? Kushi? 0.05 into 10 power minus 6. 0.05 into 10 power minus 6. Yes, very good. Correct one. 0.05 into 10 power minus 6, otherwise 54 into 10 power minus 9, anything you can take. Basic problem only. Finished? 0.05 into 10 power minus 6. Get up. Come here. You wanted that only, no? You are waiting when she will call like that. అరే రోగిష్టి రోగం వచ్చిన లాగా ఉండొచ్చు కదరా. So y is equals to FL by A into delta L you will take. So what I am asking here, elongation. So that delta L is equals to FL by A into Y. Force is how much I said? 3 kilonewtons. Nothing but 3 into 10 power 3 you have to take 3 kilonewtons. And length of the wire is how much? 4 meters. That divided by area is how much? 2. And then Young's modulus is 110 into 10 power 9. At that time you will get it as 0.0545 into 10 power minus 6. You can even take it as 54.5 into 10 power minus 9 meters. I think this one will come in millimeters, I guess so. Correct, meters and idu kuda meters. Yes. Everything is in meters. That is about the delta L. Very easy, basic substitution only. Next problem. A cable is replaced by another one of same length and material, but twice the diameter, comma, how will this affect the elongation? Under a given load? How does this affect the maximum load, comma, it can support without exceeding the elastic limit. So you have to find out the delta L ratio, elongation ratio, and also mg ratio. Load nothing but mg, and first of all you have to find out about the elongation ratio. Elongation is how many times, and then load will be how many times, you have to find out. Read the question properly first of all. Understand the question and then take the relation between them first of all. Take two wires. You have to find out the E1 by E2 ratio, M1G by M2G ratio. Elongation is how many times? 4. 1/4 of 4. E2 is 1/4 of E1, otherwise E1 is 1/4 of E2. 4 times of E1. 1/4 of E1. Then load. Four times load will be. Yes. Elongation is 1/4 and then load will be 4 times. See that, look at the problem, you might be confusing in that, you can do that easily. See that a cable is replaced by another one of same length is same, L1 is equals to L2 they are saying, L2 is equals to L1, and what they are saying, but the twice the diameter of D2 is how many times? 2 times of D1, that is what they have given in the question. After that what they are asking, see, how will this affect the elongation under a given load? Under a given load, nothing but they are saying that same load is there. Load is same for both the cases. Nothing but you are saying here is F1 is equals to F2. Means that is how much? Mg only. Under a given load, only one load is given for both the wires. So, how it is affecting the elongation? Nothing but same material or different material? Same material, nothing but what I can say? Y1 is equals to Y2. Then Y is equals to FL by AE is the formula for us. Now you have to find out the elongation ratio only about the first wire and then about the second wire you have to find out. Y is equals to FL by AE for the second wire also. Here what is same here? Area is not same. Force is same, right? Force is same, length also same, and then Y is also same. So clearly what I can write here, E is inversely proportional to area. Correct? E is inversely proportional to area here. So clearly E1 by E2 is equals to what I can write? A2 by A1. So that E1 by E2 is equals to A2 by A1. Now E1 by E2 ratio you have to find out. Then A2 nothing but what? Pi into D2 square, right? Pi into D2 square, that divided by pi into D1 square. D1 nothing but diameter you have to take radius. Radius is equals to how many times? D by 2 times. So that R1 is equals to how many times you will get? For example, D2 is equals to 2 times of D1 nothing but what I can say, 2R2 is equals to 2 into 2 times of R1, right? Diameter nothing but what? However, the 2 gets cancelled. Again R2 is equals to what will get here? R2 is equals to 2 times of R1. If the diameter D2 is 2 times of D1 nothing but R2 also equals to what? 2 times of R1 only. So that pi R2 square divided by pi R1 square you will get. Pi gets cancelled here. R2 by R1 whole square. Then R2 is how much here? 2 times of R1. That divided by R1 whole square. Then R1 gets cancelled. So E1 by E2 is equals to what you are getting here? 4. Then E2 is equals to how many times? 1 by 4 times of E1. That is the first question. So here they are saying that Y1 is equals to Y2, same material, length is also same only, but the diameter of the second one is twice the diameter of the first one. D2 is 2 times of D1. If the diameter is 2 times means radius also what? 2 times only. So the R2 also equals to 2 times of R1 under a given load, nothing but load is same. So M1G is equals to M2G they are saying. Now you have to take the, everything is same, nothing but take the relation between elongation and then area. Elongation is obviously whenever E is going this side, then E is inversely proportional to area only. So clearly what I can write here, E1 by E2 is equals to A2 by A1 pi R2 square by pi R1 square. Then R2 by R1 ratio is how much here? R2 by R1 is equals to how much? 2. So that 2 whole square will get, that is 4. Then E2 is equals to 1 by 4th of E1. That is about the first question. In that, if you see the second question, how does this affect the maximum load if it can support without exceeding the elastic limit? Now everything they are saying about the same problem only, but now they are telling about load is different. Load is different, nothing but what they are saying, M1G is not equals to M2G. We know the elongation relation here. We got the elongation relation. We know the areas and all. So find out F1 by F2, that's it. Find out the F1 by F2. How much you will get? 4 times you will get. F2 is 4 times of F1 you will get. That is the answer. Why? Because force is directly proportional to area, right? See that, without taking anything also we can do that. Everything is same, nothing but force is directly proportional to area. So F1 by F2 is equals to what I can write? A1 by A2. Then pi D1 square by pi D2 square you can take. Otherwise pi R1 square by pi R2 square. Then pi gets cancelled here. R1 by R2 ratio is how much? R1 by R2 is equals to 1 by 2, right? So that F1 by F2 is equals to 1 by 2 whole square. Then clearly what I can write, F2 is equals to how many times? 4 times of F1. That is the answer. How many of you got both correctly? Very less, 3 members only. Good, good, very good. Only first one at least? Yes, good. Second, you did not understand the terminology, I guess. Load ratio you have to find out. Yes, next problem. A brass rod having diameter 4 millimeters. A brass rod having diameter 4 millimeters and y is equals to 9 into 10 power 10 Newton per meter square. Then find the force required to stretch it by 0.1% of its length. Stretch it by 0.1% of its length. Do that. Force required, you have to find out. Yes. ಕೆಳಗೆ What is the force required? One 113 ಅಂದರೆ 113 you got. Only 3 digits you got. 113 newtons you are saying. In newtons. How much?
113.04 into 10 raised to 3.
10 raised to 3 na? No. You get in terms of 1000 newtons. Nothing but 1136, otherwise 1146, like that you will get. Take the 11? Yes, very good. Very good, that's correct. ಹರ್ಷ ಹೋಗಿ ಮೇಕಪ್ ಮಾಡ್ಕೊಂಡು ಬಾ. We'll get answer as approximately 1130. Yes sir. Directly force only, everything given you have to find out the force, direct formula itself. You have to take y FL divided by A into delta L as the Young's modulus. They are saying that you have to find out the force to stretch the wire by how much percentage they are saying. See that a brass rod having the diameter of 4 millimeters. They said that diameter is 4 millimeters means radius is how much? 2 millimeters. Radius is 2 millimeters, and after that Young's modulus is given as y is equals to 9 into 10 power 9 Newton per meter square. That is the Young's modulus. Then find the force required to stretch it by how much percentage? 0.1%. 10 na? 10 power 10. So you have to find out the force required to stretch it by how much percentage? 0.1% means what they have given? Delta L by L, fractional ratio they have given. So that delta L by L percentage they have given, so that 0.1 by 100. That is the delta L by L ratio. Nothing but I can take it as 1 by 1000. 1 by 1000 I can take. Now you have to find out the y. So not y, you have to find out the f. So that f is equals to what I can write here? F is equals to YA delta L divided by L. Correct? Instead of delta L by L, what I can take? 1 by 1000 I can take. Young's modulus is how much? 9 into 10 power 10. Area is how much here? Pi r square, right? 22 by 7 into radius is how much here? 4 into 10 power minus 6 will come. Why? Because 2 millimeters. 2 into 10 power minus 3 meters you have to take. That into delta L by L is 1 by 1000. Whenever you solve this one entirely, what will you get the answer as? 1130. Point whatever it might be, just leave about that. 1130 newtons. That is the force required. Correct? A very small twist is there. That is, they have given the percentage change in the length. That's it. Now one more problem, important. Find the elongation in copper and aluminium. Find the elongation in copper and aluminium. If the Young's modulus of aluminium and copper are, if the Young's modulus of aluminium and then copper are 7 into 10 power 10 Newton per meter square, 7 into 10 power 10 Newton per meter square, and copper is 5 into 10 power 10 Newton per meter square. And the lengths of Lengths of the two materials are 1 meter and 0.22 meters. 0.22 meters. And the diameters are 1 mm and 1.4 mm. Those are the given values, and now you have to find out the elongation. So elongation you have to find out. First one is aluminium hanged by 4 kg mass, and then copper, then 7 kg mass. Check that properly. Think first of all what you have to do, and then get the answer. Little calculation is required, you have to do that. Do that. Everybody can get the answer. Easy only. Direct substitution. That's it. Nothing is there. But mainly you have to identify the force, applied force. That's it. Zero 0.5. First one is correct. Second one you check. Aluminium is correct. 2 millimeters is the correct answer for the aluminium. For the copper, what will you get? Make easy calculations. See that I'll do. Now here mainly you have to observe is every value they have given. Diameters they have given here. Diameter nothing but radius will be how much? Radius of aluminum is 0.5 into 10 power minus 3, and then radius of the copper is how much? How much radius of copper is? 0.7 into 10 power minus 3. That is the radius of aluminum, and then copper we have taken. And after that length they have given, and then Young's modulus they have given, but the force is not given. For that purpose what you have to do nothing but first of all find the force. So whenever you find the force here, see that this aluminum wire is bearing how many masses? First of all tell me. 2 masses, right? One is 4 kg and then another is 7 kg. This aluminum is bearing 11 kg of mass. So that force on aluminum is how much? Nothing but 110 newtons. Is that correct? It is bearing 11 kg mass, nothing but weight will be how much? 110 newtons. Mainly that only you have to take. Next, copper is bearing how many masses? Only one mass, that is how much? 7 kg only. So that force on copper is 70 newtons. Have you taken correctly these two are? Yes, aluminum is bearing, aluminum wire is bearing. For example, if I lift the aluminum wire, at that time I am lifting 11 kg of mass. If I lift only copper wire, at that time how much I am lifting? Only 7 kg mass. So that force on aluminum is 110 and then force on copper is 70 newtons. Sometimes they will ask the ratio only, at that time it will be more easy as compared to the normal separately if you do. So I'll try to find out the ratio only. However, you can compare with your answers. So Y of aluminum divided by Y of copper is equals to what I can write here? FL divided by AE of aluminum everything, that divided by FL by AE of copper. So Y of aluminum is how much here? 7 into 10 power 10, that divided by Y of copper is how much? 5 into 10 power 10, that is equals to F1 by F2. F1 by F2, F aluminum is how much for us? 110 newtons, that divided by F2 is how much? Copper is 17 newtons. Forces ratio is finished. Next, length ratio you take L1 by L2. L of aluminum is 1 meter, L of copper is how much? 0.22 meters. Then this one also finished, length also finished. Next one is A2 by A1. A2 by A1 nothing but what? Pi into R2 square. R2 is how much? Copper is how much? 0.7 into 0.7 into 10 power minus 6. That is A2. That divided by what you have to take? A1. A1 nothing but area of aluminum. How much? That is pi into R1 square. R1 is how much? 0.5 into 0.5 into 10 power how much? Minus 6. That is about the areas. Then what you have to find out? Obviously elongation only. Elongation of the copper divided by elongation of aluminum will get F1 by F2, L1 by L2, A2 by A1 and then E2 by E1. That is what you have to take. Then here's 10 power 10, 10 power 10 got cancelled, 0, 0 got cancelled, pi, pi gets cancelled, 10 power minus 6 also gets cancelled. That's it. Anything else is there? This 7 pi 5. What you have to find out by the way? E2 by E1, E of aluminum by E of copper. That is equals to, what will get here? E of aluminum is 5 will go here. So 11 into 5 into 0.7 nothing but 7 by 10 into 7 by 10 I will take. That divided by, what will get here? 7 will get down, right? So that how much it will be? 7 into 7 into 0.2 nothing but 22 by 100 into 5 by 10 into 5 by 10. Finished? Anything else is there? Aluminum came and then copper came, this gone up and then that gone down. Correct. So that here what I can cancel here directly, 7 7 gets cancelled. Then anything else? 10 10 10 10, 5 5 also gets cancelled. Then this will be how many times? 20 times. Then this will be how many times? 2 times. So what is the answer will get? 20 by 2. Correct? Anything else is there? Nothing is there. See that? 7 7 got cancelled. 11 and then 2 got 11 and then 22 got cancelled. So the 2 is remaining in the denominator. 5 5 gets cancelled. One more 5 and then 100 gets cancelled. This 10 10, this 10 10 gone. Correct? Then what is the ratio you will get here? 10. Ratio is 10. Nothing but you will get aluminum by copper ratio is So that E of aluminum is 10 times of E of copper. I think you will get the answer as 2 millimeters. So first one is E of aluminum is 2 millimeters, and then E of copper is how much? 0.2 millimeters. That's it. Those will be your answers. You might be having doubt that how you got this one. Find out any one and then you will get the automatically another one. Why I have done in ratio? Nothing but it will be easy to cancel. Instead of carrying so many unknown values, everything easily got cancelled here. So only you can do the ratio. By seeing the how to get to know that how to do the ratio, nothing but here only we can observe. Here 1.4 is there, nothing but 7s will come. Here 7 is there, so that I can cancel. Somehow I can cancel here. And also here 10 power 10, 10 power 10 we can cancel easily. And then here weight is how much for this one? 110 newtons. Here 11 is there, here 22 is there. Then we can cancel that 2R also. So that take the easy way, search the easy way to solve the problem. If you find out separately, it will take much time. And if you find any one only, and then you can get automatically the second one. How many of you got correctly all the answers? 2 answers? Only one member. Good, Gautam. At least one aluminum. Good. Copper you did not get. Copper you got. Good, good. Finished? Copy that fast. Next problem. A rod capital AD, a rod capital AD consisting of three segments, AB, BC and CD. AB, BC and CD joined together hanging vertically from a fixed support capital A, from a fixed support at A, at capital A, from a fixed support at capital A, full stop. The lengths of three segments are 0.2 meters, 0.3 and 0.15. Fan increase my speed. 0.15. 3 दल्ले ಇದೆ. Full stop. The cross section area of rod is 10 power minus 4 meter square uniformly. 10 power minus 4 meter square uniformly. Full stop. A weight of 10 kg. Is hung from point D. Calculate the displacements of B, C and D. Calculate the displacements of B, C and D. In bracket YAB is equals to 3.5 into 10 power 10 Newton per meter square. Then YBC 5 into 10 power 10. YCD 2 into 10 power 10. YCD 2 into 10 power 10. Solve that. First of all, understand the question. That's a diagram. A, B, B, C, C, D are different regions. They are having different Young's modulus. Everything is different only. Massless.